Welcome to Surviving Statistics, lesson number 2. This and my other lessons entitled Surviving Statistics are based on my textbook, Surviving Statistics, A Professor's Guide to Getting Through. In lesson number 2, we will talk about frequency distributions in tables. We'll talk about displaying frequency distributions in column and bar and pie charts. We'll talk about relative and cumulative frequencies, and we'll talk about frequency distributions when you're dealing with large quantities of data. In the first lesson, we talked about descriptive and inferential statistics, and the first several chapters of this book will deal with descriptive statistics. And one of the first questions you ask about data that you have or have collected is how many? That's one of the easiest questions to answer as well. So for instance, we might be asking how many customers rate us as superior or good or fair or poor? How many of the hospital's patients are over 50 and how many are under 50? Well, we answer these questions by counting. And we're going to get a little bit more technical, but what we're really asking here is for the frequency of occurrence. In other words, how many? How many are in this category? How many are in that category? And we display the counts in frequency distributions, and we can do that as charts or tables or graphs. And we'll talk about that as we continue on here. Remember that a frequency distribution is just a breakdown of the different categories and how many observations there were in each category. So what you're seeing on the screen here is a frequency table, which is one way to display a frequency distribution. And this frequency table shows the result of a question that we asked: what is your favorite color? And altogether, you can see down at the bottom that there was a total of 157 respondents to this survey, and we can see the breakdown or the distribution or the frequency of each of the color choices. So 31 chose blue as their favorite color, 29 chose green, and so on. And a frequency table also shows us the total, as I mentioned, 157. And when you are creating your own frequency tables, they're very easy to create. It's a good idea to sort them in some way that makes sense. In this case, they're sorted alphabetically. We can also display frequency distributions in chart form. And what you're seeing on the screen here is a column, or sometimes called a bar chart. And we have a column or bar for each of the colors that we asked them, which was their favorite. And we can see just by looking here that the tallest bar is red. And so yes, we could see that numerically in the frequency table in the previous screen, but here we're seeing it visually. What you're seeing now on the screen is a pie chart. And a pie chart is another effective way to display frequencies graphically. You'll notice that on a pie chart, each color represents the different choices that the individuals chose for their favorite color. And with a pie chart, we see how each of the color choices fits into the whole. If you're looking at this pie chart again, you'll notice that each color choice has a percentage assigned to it. And because I created this pie chart in Excel, it's very easy to add percentages. But what you're seeing here with the percentages is what percentage of the whole represents each color choice. So for instance, red is 27%. Now, what we're actually describing in statistical terms here is a relative frequency. And the relative frequency is the ratio of each color choice to the entire number of observations, and then we add them all up and we get, of course, 100%. We're going to be talking a little bit more about relative frequencies as we continue on here. Here we have a frequency table that displays the data that I used to create the pie chart that we just looked at here. And you'll notice that in the table we have the color choice, and then we have the frequency, the number that chose that particular color, and we have a total down at the bottom. And then the column on the far right is the relative frequency, and the relative frequency is just like the percentages that we saw with the pie chart. Now we compute the relative frequency by taking the number of observations and dividing it by the total. So for instance, we can see that 42 people selected red. We divide 42 by 157 and we end up with 26.75%. And so we're finally getting into calculations, but after all, this is a statistics course. We saw on the previous screen that the relative frequencies add up to 100%, and we saw that graphically illustrated with the pie chart. Now the next thing that you'll need to learn about is cumulative relative frequencies, and cumulative just simply means they accumulate. And if you look at the table that you see on this screen, you'll see that the way you create cumulative relative frequencies is you simply take the first relative frequency, and for the second item in the category, which in this case is green, you add its frequency to the one above. So the cumulative frequency starting with blue is 19.75% because that's all there is at this point. Then though, for the cumulative frequency, we add the two together, and so we end up with green and blue together having a cumulative frequency of 38.22%. So those two colors together make up 38% of the respondents' choices. Then we continue to add down. We add orange, and orange is 19.11% added to the 32.22 ends up with 7.32%. And then we add yellow, and finally, red, and then we finally add yellow, and we end up with 100%. So cumulative relative frequency simply adds the relative frequency of the one category choice to the one above it and continues on down until we have 100% of the choices taken care of. Hopefully at this point you're thinking, hey, this frequency distribution stuff is pretty easy. And it is, especially when you're dealing with categorical information, such as favorite color. Now, if you examine the table that's on this screen, you're going to see that there is a category for reported gender, for pay, for residence, and favorite color. Now, the gender, the residence, and the favorite color could easily be classified into numbers, as we talked about doing that, putting them in the nominal scale, and then creating a frequency distribution. How many lived in Nampa, how many lived in Caldwell, how many lived in Boise, or favorite colors, or reported gender. The problem that we run into, though, is when we have a value, a variable that can be measured with a continuous scale, and that is the pay value, or the pay variable that you see in this table. The pay really can be anything. They could make $7.50. Hopefully they make more than that, but they could make that. They could make $110 an hour. Now, it all kind of depends, though, on what the reported pay is in the data set that you're working with. Now, this is actually a fairly large data set that's available on my website, and I'll give you the address here a little bit later. There's 421 observations, and the pay that they are reported has many different values. Now, trying to make a frequency distribution is a little bit harder, but there is a way to do it, and it does involve a little bit math, and it's really not that hard. So let's go ahead and talk about how we could make a frequency distribution out of continuous variables from a large data set. So here's an example of what I was talking about in the previous screen there. Notice that we have a frequency distribution, that is the pay, and how many occurrences are at each pay. And so just taking a look at this, between $9 and $10.40, we have 9, one at $9, one at $9.50, one at $9.90, two at $9.95. And again, with 421 observations as we have in this data set, you could see that that frequency distribution would be huge. There would be way too many values, and many of our values are just going to report one observation. And so there's a better way to do this. We're actually going to learn how to categorize the continuous variables and put them into really categories like we did with the favorite color and the other items that were very easy to put into a frequency distribution. So here's an example of what I was talking about in the previous screen there. Notice that we have a frequency distribution, that is the pay, and how many occurrences are at each pay. And so just taking a look at this, between $9 and $10.40, we have 9, one at $9, one at $9.50, one at $9.90, two at $9.95. And again, with 421 observations as we have in this data set, you could see that that frequency distribution would be huge. There would be way too many values, and many of our values are just going to report one observation. And so there's a better way to do this. We're actually going to learn how to categorize the continuous variables and put them into really categories like we did with the favorite color and the other items that were very easy to put into a frequency distribution. The first step in in creating a frequency distribution for a large list of continuous variables is to determine the number of classes. And with the example that I'm showing you here again, coming up with just a classification or a range of each dollar value may work, but it really might not be correct statistically. And so we're going to learn a formula that'll enable us to compute exactly the number of classes or categories we should use with the data. At any time you like, you can stop the video and just play along. In this case, you could download this particular file. It's called Pay Survey. It is available on my website. But as I mentioned before, there are 421 observations, and that's a quite large number to do a frequency distribution without knowing the proper categories and classes and ranges. So let's go ahead and continue determining the correct number of classes. Alright, we're finally ready to go ahead and start creating a frequency distribution for this large data set using the quantitative value of pay. Our first step is to determine the number of categories or classes, and we'll use the variable k for that. Now, the rule of thumb, and it's just a general rule of thumb, but it works out pretty good, is you determine the number of classes by taking 2 to the power of k until you come up with a value that is larger or equal to the number of observations. And I've been making a big deal of the fact that this data set has 421 observations. And so we need to come up with a number of classes in which we take that 2 to the power of that, which will equate to something that is larger or equal to 421. So if you look at the table here, we can start with just very simply going to 2 to the power of 2, to the 3, to the power of 4, and so on, when we finally come up with 2 to the power of 9, which gives us a value of 512, which is greater than or equal to 421. So using this rule, this formula, we will use 9 classes. The next step, and we'll see that in just a second, is to determine how wide, or the width, or the interval of those classes. Okay, after we've determined the number of categories or classes, the next thing is to determine the width. Now, in my example that I started with just guessing, I ended up with a width of $1, and that really wasn't correct because I ended up with way too many classes, way too many categories. The formula that we use is actually very, very simple. We do have to know the highest value and the lowest value in the data set. And again, with this data set that you can download on my website, the highest value is $27.10 and the lowest value is $9. So you can see here on the screen the formula for I, the interval, is the highest value minus the lowest value divided by k, and we've already computed a k of 9. So with this data set, we end up with $27.10 minus $9 divided by 9. We then get a interval of $2.01. So after we've determined the number of classes, k, and the width, or the interval, I, we then can go ahead and make a frequency distribution. Now, I would encourage you strongly to use Excel or some other spreadsheet when you're working with statistical information, especially with large quantities of data, as in this case with 421. The example that you see on the screen here shows a frequency distribution, but rather than having to manually count each of these values in a data set of 421 or even larger if you're doing research, it makes a good sense to use Excel. In this case, you're seeing the result of an Excel pivot table. And of course, I do have some lessons on how to create pivot tables and use Excel as well. And as I mentioned before, you can download these files on luthermaddy.com. Okay, let's just do a quick review of Chapter 2 of Surviving Statistics. We've talked about frequency distributions, and a frequency distribution is simply a count of the number of observations in each category. We can display a frequency distribution in a table format with numbers, or we can also display it graphically with a pie chart, a column chart, or a bar chart. When we display it as a pie chart, it gives us a graphic representation of the percentage of each category. We call that relative frequency. Now, to compute a relative frequency, we take the number of observations in a specific category and we divide that by the total number of observations, and we usually display that as a percentage. When we're dealing with large data sets of quantitative data, especially that is a continuous variable, we need to determine how best to make a frequency distribution. To do that, our first step is to determine the number of classes, and to determine the number of classes or categories, we take 2 to the power of k until we end up with a number that is greater than or equal to the number of observations. To determine the width, or the interval, we take the highest value minus the lowest value in the data set and divide that by the number of categories.